How to locate the epicenter deep under the ground. Now we talk about the earthquake monitoring system and how we use those data to know where the epicenter is. It's probably the high school science or physics level. The monitoring system of earthquake, I think it's easy to design nowadays. It could be a good high school project to design new one. I kind of design right now here. It's used to use like a string and weight and stuff, the mechanical type. Now it's the electronic type you can use. For example, here's the photo sensors and has a LED on top and has a mass here. And what's happened is when the box moves, this movement is very slow. We design it's like each second it's moved very tiny bit. It's going to move like 10-20 seconds. The low frequency move. So what's happened is earthquake is a higher frequency. The box moves, so this LED sensor, the light sensor, moves. So this is recorded by computer every millisecond, and we need to have this 3 different directions, X, Y, Z, because when earthquake come, there's a longitudinal wave, which is like a sound wave. It's vibrate in the same direction as the wave direction, and also it's go vertical and horizontal. Okay, so computer detects 3 different directions and merge them together. Then it's look like primary wave and secondary waves and back wave, and sometimes this go together here, but most of the time we see clear difference on the arrival time of the primary wave and secondary wave. There is a time delay, the t second, and the reason for this is the P wave is longitudinal wave. It's like it's push and pull kind of wave from the epicenter. So it's usually, roughly speaking, twice as fast as a secondary wave, which is a vertical and horizontal. So we're talking about horizontal or vertical is S wave. Then P wave is like a sound wave. Okay, and back wave is something different from epicenter. Usually the wave propagate the surface, back wave come underneath. Okay, so it's a whole lot more complicated wave. So what we do is we have the rule of thumb about 5 kilometers per second. If t is 5 second difference, then probably the distance to the epicenter is about 25 kilometers. Okay, that means P wave speed is about 10 kilometers per second, and S wave is 5 kilometers per second. Okay, now once we get the distance r, once we get the distance r, we need 3 data. Okay, monitoring system get R1, R2, R3. We draw the circle. Now here the circle is the circle on the ground, but actually it's a sphere. Okay, and the epicenter is somewhere on this sphere. Okay, so for example R1, R2, the intersection of the sphere, this is a circle, vertical circle. If we make a vertical plane here, epicenter is somewhere on this plane. Same thing happened to R2 and R3. Okay, epicenter is somewhere on this vertical plane. So this is going to be the epicenter. Okay, now we measure the distance to epicenter for this circle. Say it's a S, right? So situation is we get S, the distance, and actually this is the real distance. So from here we can easily calculate R square minus S square. Okay, and that's the way we know the depths of the epicenter. Okay, now let's talk about tsunami. Why earthquake always cause tsunami? Okay, you learn the Huygens principle. What's happened is, say you have ocean, and here some landmass slide down. What's happened is there is an injection of the wave here happens. The Huygens principle tells you that this injection of wave is going to propagate all direction. So there is the wave running this way, but the depths get shallower and shallower, so the wave height grow because total mass of the water is maintained and it's shallower. That means there's no other place to go, it's swell up. Okay, so the 10 meter here may become 30 meters, and that's going to be the tsunami. So depend on the type of the earthquake. If the bottom slide down or slide up, then it's called tsunami. If it's a shear direction, it's just horizontal direction movement, then it won't cause any tsunami. So it's type of earthquake cause tsunami. Okay, I hope you enjoy these videos, and please check out the videos. We have more interesting subject. Thank you.